seventh graders. We're going to talk a little bit about some compound events and some specific types of compound events. So compound events are going to be when we have two or more events happening. And again, so this could be something like you're rolling a dice and you're flipping a coin. It could be like the combinations on a lock, kind of like we talked about the other day with the fundamental counting principle. So where each number that's part of the code is its own event. So a compound event is going to be something that has two or more events. And compound events can be either what we call independent events or dependent events. And so when we talk about the definitions of these, I like to try to think of if you're independent, okay, you can kind of stand alone, you can be by yourself. If you're dependent, then you kind of like rely on someone else. And so that's a good way to think of the difference between independent events and dependent events. So independent events is the probability of two or more independent events. We can find that by finding the product of the probabilities of each event. And we'll talk about some examples of independent versus dependent first. So some examples of independent events would be something like if I roll a dice and if I flip a coin, okay, and I want to know the probability that I get, we'll just say a 6 on the dice and heads on the coin. All right, whatever I roll on the dice is completely separate than what I flip on the coin. All right, one of those events is not affecting the other. Okay, so it doesn't matter what I roll on the dice, that's not affecting what I can flip on the coin. So we would call those independent events. Another example of an independent event would be if you think back to our bag activity with the colored cubes, if you take a cube and you put it back in, all right, and then you shake them up and you draw another cube, you're resetting the probability of drawing whatever color cube from the bag. And so that would be another example of an independent event. So you're going to find the different probabilities, I should say, of the separate events, and then multiply them together to figure out the overall probability of those multiple events happening. So here's just a quick little example. It says you spin the spinner and flip the coin. So again, whatever happens on the spinner is not affecting that coin flip. Okay. And so if I want to know the probability that I spin a prime number and flip tails, okay, those two events happening together, I'm going to figure out, first of all, the probability of me getting a prime number, and then the probability of me getting tails. Okay, so when we look at the prime numbers, here I have 2, 3, and 5 are all my prime numbers. And so I have a 3 out of 5 chance to get prime. The probability that I would flip tails on that coin is 1/2. And so if we multiply those two probabilities, 3/5 times 1/2, I'm going to get 3/10. So I have a 3 out of 10 chance of spinning the prime number and spinning tails, which we could again express as a fraction, a decimal, or a percent. So if I wanted to find the probability of spinning a multiple of 2 and flipping heads, all right, same idea. I would find the probability of each of those events separately and then multiply them together. So spinning a multiple of 2, I only have the 2 and the 4. So I have a 2 out of 5 chance of landing on a multiple of 2. And I have a 1/2 chance of spinning or flipping heads. And so if I multiply those together, I get 2/10, which I can then simplify to 1/5, which is 20%. So I have a 1 in 5 chance or 20% chance of that happening. When we talk about dependent events, so if you think about depending on someone else, you're relying on them. So this is when the occurrence of one event does affect the likelihood that the other events will occur. And so we're still going to be multiplying the probabilities, but there's just going to be a little catch there. So here, if I have people are randomly chosen to be game show contestants from an audience of 100 people, you were with 5 of your relatives and 6 of their friends, what's the probability that one of your relatives is chosen first and then one of your friends is chosen second? And so if we look at the probability that one of your relatives is chosen first, Okay, this one, you have 5 relatives with you out of the 100, so then that's where we get this probability of 5/100ths or 1/20th. But now here's the catch. So one of those 100 people has now been chosen. And so now if we want to think of the probability that your friend is going to be chosen, there's 6 friends, but now we only have 99 people because that second event depends on what happened first, okay? The probability of the second event happening is affected by whatever the outcome of the first one was. So we have 6 out of 99 now, which we can simplify to 2/33. And then we would end up multiplying the 1/20th times the 2/33 and get a 1 out of 330 chance of that specific, those two specific events happening together. So if we look at some more examples of that, so a good example of dependent is going to be if you have a collection of items like in a bag or something, if you are taking either 2 out at a time or multiple out at a time, or if you take one out and you put it to the side and you don't replace it back in the bag, then you're affecting the probability of what's left inside the bag. So we're going to look at a couple of quick examples of some independent and dependent events. So if we look at number 5 here, it says spinning a 3 and flipping heads. So we're spinning a spinner and flipping a coin, find the probability of the compound event. So spinning a 3 and flipping heads. First of all, it's always good to notice if it's an independent or dependent event. In this case, because I'm spinning a spinner and flipping a coin, and those are completely two unrelated events, these are going to be independent events. So the probability that I would spin a 3 on my spinner is 1/4. The probability that I would flip heads on a coin is 1/2. And if I multiply those together, I'll get 1/8. If I wanted to know the probability of not spinning a 2 and flipping heads, so if I look at my spinner, the probability that I don't spin a 2 would be 3/4. The probability that I can flip heads is 1/2. And that would give me a probability of 3/8 when I multiply them together. So now, and again, that would be an independent event. So if we look at 9 through 12, it says you randomly choose one of the tiles without replacing the first tile. You choose the second tile. Find the probability of the compound event. And so these are going to be dependent events because once I remove that first tile, all of the probabilities have then changed. Okay, so I want to know the probability that I choose a 5 and then a 6. So right now, if I look at this collection of tiles, the probability that I would choose a 5, there's 1 5 out of the 7 tiles. So I have a 1 in 7 chance. Now we're going to assume that I pulled the 5. And so now I want to know what's my probability of pulling a 6 after that 5. So now when I look at my bag, I've taken the 5 out. So I have 1 6 left I have 1 6 left, and then out of the 6 possible tiles. And so then if I multiply those together, I'm going to get 1/42. If we look at number 11, so I'm going to undo that crossing out. So choosing a number less than 7 and then a multiple of 4. So right now, so reset the bag, the probability that I choose a number less than 7, I'm going to go ahead and circle my numbers less than 7. I have 5 and 6. So I have a 2 out of 7 chance there. And we're going to now assume that I got one of those. And so now we're going to look at what my probability of getting a multiple of 4 would be. And so when I look, I only have 2 multiples of 4 left. And so out of the 6 tiles that would be left in my bag. And so 2/6, we could either simplify this fraction right now or we could simplify in the end. I'm going to go ahead and simplify it now. So I know that 2/6 will simplify to 1/3. So now I can go ahead and multiply straight across. 2 times 1 is 2, 7 times 3 is 21. So there's a 2 in 21 chance that we would choose a number less than 7 and then the multiple of 4. All right, have a great day.